Welcome to this unit, Introduction to Systems Thinking. Causal relationships will be explained as a means of reflecting system thinking within the framework of basic concepts. In this unit, I want to introduce you to a powerful and transformative concept in problem-solving and decision-making, systems thinking. In this unit, I will explain what systems thinking is, why it's essential, and how it can be applied in various aspects of our lives. What is system? Merriam-Webster Dictionary defines a system as a regularly interacting or interdependent group of items forming a unified whole. A system is a set of interconnected and interdependent components that work together to achieve a specific purpose or goal. Systems can be found in various contexts, including nature, engineering, biology, social organizations, and many other fields. The key characteristics of a system include components or elements, relationships or interactions between these components, a defined boundary that separates the system from its environment, and a specific purpose or function that the system is designed to fulfill. Differences between systems and heaps. We call the non-systems as heaps. Systems. Systems are composed of interconnected components that work together to achieve a particular purpose or goal. These components can vary widely and are typically organized in a specific structure or arrangement. Heaps. Heaps refer to the purposeless and incompatible structure of data elements or physical components. It is like a sand dune. Purpose. Systems. Systems are designed to achieve specific objectives or functions. They serve various purposes and can be found in many domains, including engineering, biology, sociology, and more. Heaps. Heaps are primarily like data or material waste. They coexist as groups/lumps with no semantic unity between them. Interactions. Systems. Interactions and relationships between components are a defining feature of systems. How components interact with each other and with their environment is crucial to understanding the system's behavior. Heaps. Heaps do not focus on interactions between components. They are primarily concerned with the sequence of stages organization of data elements based on their values. Boundary. Systems. Systems have a defined boundary that separates them from their environment. This boundary helps delineate what is considered part of the system and what lies outside it. Heaps. There is no limit to the stacks. They are often considered part of a larger stack. Domains of application. Systems. Systems thinking is applied in a wide range of fields and domains, including engineering, biology, environmental science, business, and more. Systems are a fundamental concept in understanding complex processes. Heaps. Heaps are simple sets. They do not contain complex structures formed by relationships. In summary, systems and heaps are fundamentally different concepts. Systems are holistic entities, composed of interconnected components working together to achieve a specific purpose, while heaps are stacks with a primary focus on the value-based prioritization of elements. What is systems thinking? At its core, systems thinking is a holistic approach to understanding and solving complex problems. It encourages us to look beyond isolated events and instead view the world as a network of interconnected elements and relationships. This approach recognizes that actions have consequences that ripple through the entire system, often with unintended outcomes. Why is systems thinking important? Systems thinking is essential because it helps us address the growing complexity of our world. In an increasingly interconnected and interdependent global society, the problems we face are rarely simple. Traditional linear thinking often falls short in understanding and solving these complex issues. Systems thinking provides a more effective way to navigate these intricacies. Applications of systems thinking. 1. Business. In the corporate world, systems thinking is used to improve organizational performance, enhance supply chain management, and develop sustainable business practices. 2. Environmental issues. Systems thinking is invaluable for addressing complex environmental problems like climate change and ecosystem degradation. It helps us understand the intricate relationships between different environmental elements. 3. Healthcare. Healthcare professionals use systems thinking to improve patient care, reduce medical errors, and streamline hospital processes. 4. Education. Systems thinking can revolutionize education by considering the holistic development of students, the dynamics of the learning environment, and the impact of educational policies. 5. Public policy. Policymakers utilize systems thinking to address intricate societal issues such as poverty, crime, and public health. In conclusion, systems thinking is a powerful framework that allows us to better comprehend and address complex challenges. It's a mindset that encourages us to see the bigger picture, recognize the interconnections in our world, and make informed decisions that consider long-term consequences. As you go forward, I encourage you to apply systems thinking in your personal and professional life, as it can lead to more effective problem-solving and decision-making. Thank you for your attention.